Okay, here is the key that I promised you. Number 1, we already sort of did part of number 1 together, but I really think we probably just need to start from scratch here. So this says, at time t, a population of bacteria grows at a rate of this, and it gives me grams per day, so this is a rate, where t is measured in days. By how many grams has the population grown from t equals 0 to t equals 10? So they give me a rate of grams per day. I only want grams, so I'm going backwards. Okay, so if I have something and I take the derivative, that gives me a rate. If I have the rate and I want just part one of, and I just want the numerator part, the grams, then I integrate and go the other way. So I'm going to integrate from 0 to 10, 5 times e to the 0.2 t plus 4t dt. Do not forget this dt part. I know this is a multiple choice question, but we can't get sloppy on multiple choice because we can't get sloppy on free response. Now, this is not just a plain old polynomial, but I do have 2 terms, and I can integrate them separately. You can rewrite them separately if you want to. You don't have to. I'm going to here just so I don't lose anybody. So this is equal to, and then so I'm going to just do this first part here. Not only that, I have this coefficient of 5 that I can pull out front here. So I'm going from 0 to 10, e to the 0.2t dt plus the integral from 0 to 10 of 4t dt. And I need a dt on both of those. Then I can look at them separately because I'm going to need to use some u substitution in the first one, and I don't have to in the second one. So this just kind of keeps a little bit more clear for yourself. So here is where I'm going to need to use my u because this is not just a plain old t. It is 0.2t. Now that's a decimal. 5 is a whole number. 0.2 is a pretty simple decimal, so I really think I'd rather look at it as a fraction. This means 2/10, like you literally just said the fraction. 2 over 10, which is 1/5. So I'm going to change this to 1/5 t. Okay. Then again, since this isn't plain old t, I can say that u is equal to 1/5 t. Right? And then that means that du is equal to 1/5 dt. So in order, this is going to be my e to the u here, this is my dt, but I need to get a 1/5 in here, which means I need to divide by 1/5 over here, which is the same as multiplying by 5. So when I rewrite this, I'm going to get 25 times the integral from 0 to 10 of e to the u du plus, and then I can go ahead and integrate this. This is going to be 4t squared over 2, and I'm going to evaluate that from 0 to 10. Okay, so now when I integrate this, I'll move over here. When I integrate e to the u, I get e to the u. And this is u, so I'm going to go ahead and kind of skip a step here and say this is 25 times e to the 1/5 t plus 4t, well, since that's 4t squared over 2, I'm going to make that 2t squared. And I'm evaluating that from 0 to 10. Okay, so when I evaluate, I'm going to take 10, and I'm going to substitute it in to both of these. So this is going to give me 25 times e, so when I put 10 in here, that's 10 over 5, which is 2, so that's e squared, plus 2 times 10 squared, okay. Then minus, this is all in one thing, and then I need to open a big parentheses here. When I substitute 10 into here, I'm sorry, when I substitute 0 into here, that makes the exponent 0, which makes this 1, so this just gives me 25 plus, and then that's just, so this is going to give me 25e squared. 10 squared is 100 times 2 is 200 minus 25. So that would give me 175, and my answer is C. Okie dokie. Number 2, which of the following is a solution? So we can actually separate and integrate here and then use this initial condition. So when I do this, when I'm going to divide both sides by y, so I'm going to get 1 over y dy equals secant squared x dx. Okay? So now I have all my y's on one side, all my x's on another. I cannot forget to actually write this, my long s in there. And then I'm going to integrate. When I integrate 1 over y, that's the natural log of the absolute value of y. And that is equal to, so when I integrate secant, so remember, psst, okay, the p is silent when you do it, not silent when you say it. And then secant squared, the derivative of secant squared is tangent. The derivative of tangent is secant squared, so they go backwards the same way. So this is just going to give me tangent x plus c. Can't forget my plus c. Okay, so now I need to get my, and there's 2 different ways I could work this. And maybe I'll do it both ways, because I think I saw y'all do it 2 different ways. So I could right here substitute in my initial condition. Okay, so let me do that, and then I will come back and do it the other way. So I can either solve for y first and then substitute in my initial condition, or I can solve for y and then do my initial condition. So let me just go ahead and do this way first, where I'm going to use my initial condition right here. Natural log of the absolute value of -1, and we'll talk about the pros and the cons of them. And that is equal to the tangent of pi fourths plus c. Okay, so the natural log of the absolute value of -1 is the same thing as the natural log of 1. And so I know that's my parent function, so this is 1. This is going to give me 0, so 0 equals 1 plus c, so c equals -1. So then when I want to substitute that back in here, that gives me the natural log of the absolute value of y equals the tangent of x minus 1. So to get y out of the natural log there, I'm going to make e the base on each one of these. And then this gives me, this just gives me the absolute value of y, and that's equal to e to the tangent of x minus 1. Now, when I look at my answer choices, the exponent and everything, this all looks good, except that's negative and this is not. But this is the absolute value, okay? So that means it can equal, so y can either be this or negative this. And when you look up here, your y is negative. That's how we know this one's negative and B is my answer. Okay, now let's work it the other way. So this is one way to do it. Here is another way to look at it. Let's go ahead and solve for y here, which means I'm going to make e down here. So e to the natural log of the absolute value of y is going to give me the absolute value of y equals e to the tangent of x plus c. And then I'm going to do a couple of extra steps in here that you could skip, but I want you to remember what we were doing with this whole plus c thing in the exponent. So at this point, I'm going to drop my absolute value, and I'm going to tell you why here in just a second. So this is e to the tangent of x plus c. So this gives me e to the tangent of x power times e to the c power. Because remember, when we have the same bases, we add the exponents. So e to the c is just some constant. So I can say y is equal to c times e to the tangent of x. Now, when I do that, whatever sign this is, whether it's positive or negative, gets absorbed by this because he's all powerful. It's some constant that I don't have to worry about that absolute value anymore. Then at this, so that's why I got to drop it. At this point, I am going to use my initial value. So my y value was -1. There's a different color. My y value was a -1, and that's equal to c times e to the tangent of pi fourths. So that means that -1 equals c times, oh, that's not a c, c times e, because that's just going to be e to the first power, right? Trying to get c by itself, so -1 over e is equal to c, which means that c is equal to negative e to the -1 power. So when I go and substitute it back in over here, back at this point right here, this is going to give me y equals negative e, because that's my c value, to the -1 times e to the tangent of x. Now, two bases that are the same, I add the exponents. That's where we get y equals negative e to the -1 plus tangent x power. Okay, so just two different ways to go about it. And which one is easiest is a matter of opinion. Okay, next one. Which of the following is a solution to, and I know this is printed weird because that's not an n, or that's a y double prime. That's what that is right there, double prime. It just doesn't really look like it. So I really need to find y double prime on these and try them out. So if y equals e to the 3x, then y prime is equal to, I use the chain rule, e to the 3x is e to the 3x, and then I take the derivative of the exponent, which is 3. So when I do y double prime, that's going to give me 3e to the 3x times 3. So that's going to give me 9e to the 3x power. Then I'm going to substitute it in to this and see what happens. Y double prime is 9e to the 3x minus 9 times y, which is e to the 3x. And that does equal 0. I think A looks good, but I will work through the other ones as well. All right, so good test-taking strategies is to not just, if we think it's A, we should still check our other options here. So on B, if I take the derivative, y prime would be 3e to the x, and y double prime would be 3e to the x. So then when I substitute in, I get y double prime, which is 3e to the x, minus 9 times 3e to the x, and that does not equal 0. So my answer is not B. Then I will try this one. The derivative of sine is cosine, and I'm going to have to use chain rule here, so this will be 3 cosine of 3x. Then y double prime, the derivative of cosine. So remember, you can do sine, cosine, negative cosine. Taking the derivative of cosine, we're going to get negative sine. So this is negative 3, just negative 3 times, and then sine, and then I have to take the derivative of the interior there because that is chain rule. So negative 3 times 3 sine of 3x, which is just negative 9, but I'm not even going to bother fixing that right now because when I do y double prime, which would be negative 9 sine of 3x minus 9 times 3 cosine of 3x, I ran out of room, that does not equal 0. So that is not my answer choice. Okay, so then we're going to do cosine. So y prime would be, the derivative of cosine is negative sine, negative 3 cosine of 3x. Okay. And then y double prime. Now this is where sometimes these will be your answer choices, like if you don't have that extra 9 in there because the signs flip back and forth, and then that's what makes them work and not work. But here this will be, so the derivative of cosine is negative sine, that's already negative, so it's positive 3 times 3 times the sine of 3x. And then that means we have y double prime, which is 9 times the sine of 3x minus 9 times negative 3 cosine of 3x, and that also does not equal 0. There you go. Okay, number 4. So f of t is the solution to this differential equation where k is a constant. Values of f for selected values of t are given on the table above. Which of the following expressions, or which of the following is an expression for f of t? So remember that if we have dy dt is equal to k times y, we could integrate all that if we want to, but this will always give me y equals c times e to the kt. That's something that's good to kind of commit to memory there. And then this right here, all this is my initial value. Because when t is 0, that's going to make the exponent 0, which makes this 1. So that means that this has to be 4. So c equals 4. And the only one that looks like that at all, there's a 4 in here, but we don't have the e's to the kt, my answer is A. That's it. All right, 5. So I'm going to separate and integrate. When I do that, I'm going to take the y over here, so I'm going to get 1 over y squared dy equals 3x squared dx. Put my long s in there. When I do that, I think I want to rewrite this one. If it's 1 over y, that gives me the natural log. But this is really going to be the integral of y to the negative 2 power dy equals the integral 3x squared dx. Then I get to use the power rule for both sides. So I add 1 to the exponent, y to the negative 1 power, divide by my new exponent, which is really just going to make that negative. And that's equal to, I take 3, that'll be x cubed, and I divide by 3, and then plus c. So this really gives me negative 1 over y equals x cubed plus c. And then I can actually solve for y if I want to, or I can use my initial value right here. It really doesn't matter either way. I would just go ahead and use my initial value here. So when I do that, I get, this is when y equals 1, x equals 2. So I'm going to get negative 1 equals 2 cubed plus c. So negative 1 equals 8 plus c. So then when I subtract that, I get c equals negative 9. So my equation then is negative 1 over y equals x cubed minus 9. All right, so then if I have this, I can basically take the reciprocal of both sides and get negative y. Actually, I don't even have to solve for y. I'm looking, I have x equals 1. I'm going to back that, well, I'm going to show you what you would actually do, I guess, is a good thing. But I don't need to here. So I don't need to solve for y. all I need to do is substitute that in, then solve for y. I don't have to make my equation look pretty. If it asked me for the equation, I did, but then this is, you can ignore that one, negative 1 cubed minus 9. Okay, so I get negative 1 over y is equal to, so negative 1 cubed is negative 1, minus 9 is negative 10. So if 1 over y equals negative 10 over 1, then that means that negative y equals negative 1/10, which means y equals 1/10. You would do basically those same steps with the equation if you needed to. We just didn't need to, so we don't have to. Okay, number 6. Let f be a function with f of 2 equals negative 8, such that for all points x, y on the graph of f, the slope is given by this. Slope tells me that this is the derivative, right? So this is my dy dx. Write an equation of the line tangent, so that means I need a point and a slope before I do anything else, so I don't forget those things. Because I want to write an equation of the line tangent to the graph at the point where x equals 2 and use it to approximate f equals 1.8. So we know that x equals 2, and it gives us this right here. So we know we have 2, negative 8. Okay. Slope, that means I want dy dx evaluated at 2, negative 8. And this is my dy dx. I knew it was a derivative because it told me it was my slope, basically. And then I'm going to substitute this in. 3 times 2 squared divided by negative 8. That's going to give me a negative 12 over 8, which then gives me a negative 3 halves. Okay. Now I have my point, I have my slope. I can write the equation of my line. So my line is y equals the slope, which is negative 3 halves, times x minus the x value, which is 2, and then minus 8. Then I want to approximate f of 1.8. So f of 1.8 is approximately negative 3 halves times 1.8 minus 2 minus 8. And that is a safe stop. You need to stop. All right, so the second part of this, we're going to write an expression for y equals f of x by solving the differential equation with this initial condition. So when we solve this, that means we're going to separate here. So I'm going to get, I'm going to multiply both sides by y. So I'm going to get y dy equals 3x squared dx. Then I'm going to integrate both sides here. So when I integrate y, it's going to make me add 1 to, so the exponent's 1 right now, so it's y squared over 2 equals, and this will be 3x squared over, x cubed over 3 plus c. So that means I have 1/2 y squared equals x cubed plus c. Then again, you can choose whether or not you completely solve for y first, or if we don't, what I would do is it really doesn't matter. We can leave that 1/2 there. We've got that. We simplified it a little bit. I could either multiply both sides by 1/2, but I don't have to. I'll just leave it like it is. So I'm going to substitute in my initial condition right here. So that means my y value is negative 8. So I'm going to get 1/2 times negative 8 squared. That's equal to x, which is 2 cubed, plus c. So negative 8 squared is 64. Half of that is 32. That's equal to 8 plus c. C equals 24. So I'm going to go and substitute all that, or substitute the c back into this step right here. When I do that, I will get 1/2 y squared equals x cubed plus 24. So then at this point, I need to multiply by 1/2. Here's how the c sort of absorbs stuff. If I had multiplied by 1/2 right here, I would have had just y squared equals, I'm sorry, not multiplied by 2, not by 1/2. If I had to multiply both sides by 2, I'd have y squared equals 2x cubed. This would still be plus c, but the c I got out of here would have been different than what I got. So it works out either way just fine. So this gives me y squared equals 2x cubed plus 48. And then again, I'm solving for y, so I take the square root of both sides. So y equals plus or minus the square root of 2x cubed plus 48. And then I have to decide if it's plus or if it's minus, because it can't be both. And because we had a negative y value, that means when we take the square root, we need to make that negative. So my answer is actually y equals negative square root of 2x cubed plus 48. All right, last page. Okay, so we're going to consider this differential equation and let y equal fx be the particular solution to the differential equation with the initial condition of this, which means that's a point 0, 1. The function f is defined for all real numbers. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. Okay, so I absolutely have to go through the point 0, 1. Now, and look, check your scale out. This goes to 3, so this is 0, 1 right here. And then we just kind of follow the wave. You have to be close to the right shape. So if I sort of follow the wave here, I can, from here, follow kind of like that, right? And then from here, I would follow kind of like that, and that would be good enough, okay? Now I'm going to write an equation for the line tangent, okay? So I need a point, and I need a slope, okay? Tangent to the point, so that gives me the point at 0, 1. That means my slope is dy dx evaluated at 0, 1. So that means I'm going to substitute that in. It's going to give me 3 minus 1 times the cosine of 0. And 3 minus 2. Cosine of 0 is 1, so I get 2 right there. Write the equation of my line. Y equals the slope, which is 2, times x minus 0 plus 1. Do you have to have the x minus 0? No, but I would just leave it in there and let it be. Then I'm going to estimate, so f of 0.2 is about 2 times 0.2. I could leave off the minus 0 at this point, or I could put minus 0, it doesn't matter. And then plus 1, make sure you have your squiggly equals, and you're done. Okay, so I'm going to now find the particular solution for that differential equation. So I'm going to rewrite it down here so I don't have to scroll. dy dx equals 3 minus y times the cosine of x. Okay, so I need to separate and integrate. When I do that, I'm going to get 1 over 3 minus y dy equals the cosine of x dx. Okay. Then I'm going to integrate both sides. So over here, this is 3 minus y to the negative 1. So it's like having 1 over y. So it's a natural log, but I've got to have it, it's not just a y down there. And so we want to be really, really careful. Let u equal 3 minus y. du is going to equal negative, oh, why did I put a dy right there? That is 3 minus y. And then du is equal to, when I take the derivative of this, I get negative 1 dy. Okay, so when I go to put all this in here, I need a negative dy, which means I need a negative 1 on the outside, put 1 there so I don't get confused with what's happening there. And then this is going to give me negative 1 times the integral of 1 over u du equals, now I can go ahead and take the integral of cosine, and be careful with that. Remember, this is sine, cosine, negative sine, negative cosine. So if I'm integrating cosine, I get sine of x dx plus c. All right, so then I have negative. Now when I integrate 1 over u, that becomes the natural log of the absolute value of u, and u is 3 minus y, and that's equal to the sine of x, no more dx's, oh goodness gracious. Once we integrate, there's no more dx there, sine of x plus c. All right, so now I'm going to, I can substitute in now or I can substitute in later, whatever works for you. So let's go ahead and just substitute in now, see what we can get through here. So I'm substituting in my initial condition, which is 0, 1. So that means I'm going to have a negative natural log of the absolute value of 3 minus 1 equals the sine of 0 plus c. So this is going to be the negative natural log of 2. I can drop the absolute value signs because the absolute value of 2 is 2. Sine of 0 is 0, so that is equal to c. All right, so then I've got to put my c in here. That means I have negative natural log of the absolute value of 3 minus y equals the sine of x minus the natural log of 2. All right, so now that I have this, I've got to get my y out of the natural log, but I think before I do that, I would like to get rid of that negative sign so I don't have to worry about this guy right here. When I multiply everything through by a negative, get the natural log of the absolute value of 3 minus y equals negative sine of x plus the natural log of 2. So now, again, I want to get this out of the natural log, so I'm going to make e the base, and those are going to be my exponents now. So that means this gives me the absolute value of 3 minus y equals e to the negative sine x times e to the natural log of 2. Because remember, same basis, you're adding the exponents there. Now, e to the natural log of 2 is just 2. And I can drop this absolute value, so I get 3 minus y is equal to 2e to the negative sine x. Then I'm going to subtract 3 from both sides. Negative y equals 2e to the negative sine x power minus 3. Then I multiply through by negative again. Y is equal to negative 2e to the negative sine x plus 3. Here's a little side note, okay? is that if this was a multiple choice question, which clearly it is not, this is likely to be the answer that you see. Because this is not a multiple choice question, here is kind of another way to do it where I wouldn't have to take care of this, meaning that here when I did made e the base of the exponents, this does give me the absolute value of 3 minus y equals e to the negative sine x plus the natural log of 2. Then I'm going to drop my absolute value. 3 minus y equals e to the negative sine x plus the natural log of 2. Subtract 3. So, subtracting it, I don't want to write it. Negative y is equal to negative e to the negative sine x power plus the natural log of 2. And then minus 3 down here. Multiply through by a negative. Y is equal to, oh, I shouldn't have done that yet. Y is equal to negative e to the negative sine x plus the natural log of 2 plus 3. So although these two answers here look very different, they are actually both the same. This just doesn't have this exponent simplified. And since it's free response, either way is fine. But again, on a multiple choice, you would most likely see it this way because it's simplified all the way. Now, I want to go back because after I did this one, I started thinking, okay, so we did this. We talked about our initial value. This was multiple choice. Boom, the answer has to be A. But what if it's not multiple choice, right? What if it's not, and then we need to know how to actually find these values. So if we know that we can at least get here, right? And I have these two ordered pairs, right? X, Y, X, Y. So if I substitute in the 0 and the 4, this would give me 4 equals C times E to the K times 0 power. And I know that K times 0 is 0, and E to the 0 power is 1, so we get C equals 4. That's how we get it. We also get it by just knowing the initial value, but if you're not sure, we have this. Then I have this ordered pair. So I can do 12 equals C times E to the, well, I have C. I know that's the whole purpose of this. 4 times E to the K times 2 power. All right. So then I would divide both sides by 4. So I get 3 equals E to the 2K power. Then to get that out of the exponent, I would take the natural log of both sides. All right. When I do that, the natural log of 3 is the natural log of 3, and that's equal to 2K. So then K is equal to 1/2 times the natural log of 3. So when I go back over here to substitute it in, I get Y equals C, which is 4, times E to the K, which is 1/2, times the natural log of 3 power, times T, and that's where this actually comes from. So I just felt like I should go back and actually show you how to get those numbers and not just assume that all questions would be that simple for you. So there you go. You can come see me during math time if you have questions.